the lesson video of Chapter 4.2 Chemical Bonding. In this video, we are going to learn about subtopic 4.2, that is molecular shape and polarity. At the end of this lesson, you should be able to A. Explain valence shell electron pair repulsion theory, or VSEPR, and B. Draw the basic molecular shapes, which is linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. As we begin to learn more about molecules, it is important to understand the way molecules are arranged in 3D space, because this will affect how the molecules does chemistry. Molecular shape is known as the 3D arrangement of atoms in a molecule in a space. It is also known as molecular geometry. Why is it so important to know and learn about molecular shape? Well, it is significantly important because molecular shape will affect the chemical and physical properties of a molecule. First, the chemical properties of a molecule is defined by the molecular shape, which means it defines the way the molecules react in a chemical reaction. Secondly, the physical properties. The molecular shape will determine the melting and boiling point of a molecule. So, how do we determine the shape of a molecule? This is the part where a theory is introduced that is called VSEPR theory or VSEPR theory. VSEPR theory is a model or set of rules that we can use to predict the molecular shape. VSEPR stands for V for valence, S shell, E electron, P for pair, and R for repulsion. Let us learn more about valence shell electron pair repulsion. By definition, VSEPR theory is a theory where, in a situation, the electron pairs surrounding a central atom in a molecule will repel one another and arrange themselves as far apart as possible in order to minimize the repulsion force between the electron pairs. If we could look at the carbon dioxide molecule as an example, carbon atom at the central is surrounded by the valence electrons from itself and the valence electrons from the terminal atoms of oxygen in order to form a covalent bond. As we all know, electron carries negative charge, and when atoms are in a molecule together, these electrons are repelling from each other due to the repulsion force between the electron pairs. This will allow all the atoms to be as far apart from each other as possible in order to minimize the repulsion force. Because of this, the molecule will automatically adopt a specific shape. Think of these electrons as magnets of same charge. The closer you push them together, the more the potential energy they have. In this case, things want to be at the lowest energy possible due to its stability, so if you let go, they will push apart, reducing the repulsion force and potential energies. Well, atom will do the same thing. Let's learn about the VSEPR theory by using this molecular shape simulation. The purple circle that we can see here is the central atom. Now, let's add one bonding pair electron to the central atom. How about we add another one bonding pair electron to the central atom? Well, as you can see, the new bonding pair electron added arranged itself at the very far position from the other bonding pair electron. Why has that happened? That happened because both bonding pair electrons are repelling one another due to the repulsion force between them. So, they will arrange themselves as far apart as possible in order to reduce the repulsion force according to the VSEPR theory. If we try to get both bonding pair electrons closer to each other, they will always keep repelling from each other. As we add more bonding pair electrons to the central atom of the molecule, they keep repelling and arrange themselves as far apart as possible until the molecule obtains a specific shape. In addition, we must know that the maximum number of electron pair in a molecule is equal to 6 electron pairs. Now, let us learn about how to draw the basic molecular shape of a molecule. There are 5 basic molecular shapes of molecule, so let us learn these 5 basic shapes of molecule. The first one is linear. The second molecular shape is trigonal planar. The next one is tetrahedral. The next molecular shape is trigonal bipyramidal. And the last basic shape is octahedral. Overall, these are 5 basic shapes of molecules with its respective name. Next, let us learn on how to draw the 5 basic molecular shapes according to the examples given. In order to draw the molecular shape, we need to follow a step-by-step method. The first step is draw the Lewis structure of the molecule. Next, count the number of electron pairs on the central atom, including the number of bonding pair electrons and lone pair electrons. The third step is identify the general class. And finally, draw the shape of the molecule according to the VSEPR theory. Let's say that if we have a BeH2 as an example, the Lewis structure would be like this. For the number of electron pairs at the central atom, we need to count the number of bonding pair electrons and the number of lone pair electrons on the central atom. Let's start with the number of bonding pair electrons. From the Lewis structure, we can see that beryllium's central atom has 1 and 2 bonding pair electrons. So here it should be 2. The number of lone pair electrons would be 0 because beryllium doesn't have any lone pair electrons on it. The general class would be AX2. For the molecular shape, it would be like this. This is what we call as linear shape. So, for the bond angle, as we can see, this bonding pair electron and this bonding pair electron is at 180 degrees to each other. So, the bond angle of HBEH would be at 180 degrees. BH3 as an example, the Lewis structure would be like this. The number of bonding pair electrons at the central atom of boron is 1, 2, and 3. So here should be 3. The number of lone pair electrons is 0 because boron as a central atom doesn't have any lone pair electrons on it. The general class is AX3. The molecular shape of BH3 is boron in the middle, the first hydrogen, the second hydrogen, and the third hydrogen. This is what we call as trigonal planar shape. So for the bond angle, since this bonding pair electron and this bonding pair electron is at 120 degrees to each other, therefore, the bond angle of HBH would be 120 degrees. Molecule is CH4. So from the Lewis structure, we can count the number of bonding pair, which is 1, 2, 3, 4. So we have 4 bonding pair electron, 0 lone pair electron because carbon doesn't have any lone pair electrons, and the general class is AX4. So the molecular shape would be carbon at the central, the first one is at the top, the next one is at the side, the next one is pointing forward, and then the next one is pointing backward. So this shape is what we call as tetrahedral shape. And the bond angle between this bonding pair to this bonding pair is located at 109.5 degree. So the bond angle of HCH is equals to 109.5 degree. It is PCl5 molecule. So from the Lewis structure, we can tell that the number of bonding pair electron is 1, 2, 3, 4, 5. So there are 5 bonding pair electrons with 0 lone pair electrons. The general class is AX5. So the molecular shape is P is at the central, the first one is at the top, one at the bottom, one at the side. You can draw it at the right side or at the left side of your drawing. One is pointing forward. Another one is pointing backward. So this type of molecular shape is called trigonal bipyramidal. So for this molecular shape, there are two bond angles. One is from this bonding pair to this bonding pair. They are located at 90 degrees to each other. So the bond angle for the first one is CL-PCl located at the axial position equals to 90 degrees. For the second one is between this bonding pair to this bonding pair, the bond angle is 120 degrees. So the next bond angle is Cl-PCl at the equatorial position equals to 120 degrees. SF6 molecule. So this is the Lewis structure of SF6. So the number of bonding pair is 1, 2, 3, 4, 5, 6. So 6 bonding pair electrons and 0 lone pair electrons. So the general class is AX6. So the molecular shape of this molecule is the sulfur is at the center, one fluorine at the top, another one at the bottom. One is pointing forward on the left side. One is pointing forward as well at the right side. One is pointing backward. And another one pointing backward as well on the left side. So this is what we call as octahedral shape. So the bond angle for this molecule is between this bonding pair to this bonding pair is 90 degrees to each other. So the bond angle would be FSF equals to 90 degrees.